Yes, I'm Becky Chaplin-Kramer with the World Wildlife Fund, and I'm excited to be here today to talk to you about how our conservation work is making use of space-based Earth observations. And also, before I get started, I just wanted to ask you what this phrase means to you, maximizing returns to Earth. What kind of returns do you care about? Who is here because they're interested in maximizing profits? Show of hands. Oh, come on, it's the economist. What are you doing here? Okay, who's here to find out how to maximize efficiency? All right, what about sustainability? How about justice? So what I hope I can convince you of today is that we don't necessarily always have to choose between these because Earth observations can help us find the win-wins. And those win-wins, the path to those win-wins, I would argue, is through biodiversity. So, biodiversity provides the life support system for all of us. And that's because all of these life forms that you can see on this slide, and all the ones that you don't see here, are all part of ecosystems that provide clean water, fresh air, a stable climate, and so much more. Yet, biodiversity and its contributions to our lives remain invisible unless we make them obvious. Biodiversity conservation has also struggled with this invisibility. We've traditionally lacked real-time insights about the state of biodiversity and the threats it faces across the vast extent of the planet. We need those insights to take quick action in a rapidly changing world. So that's why conservation has turned to Earth observations. Through satellites, drones, and other instruments, we can see both the state of biodiversity and many of its threats. But it's not enough to just see biodiversity and threats. We also, I know I'm supposed to talk about the non-human members of the family here, but we also, because we all depend on biodiversity, we need to know how changes in biodiversity will impact our well-being, so we can steer the planet in directions that are good for biodiversity and good for all of us. Earth observations can also help make visible the many ways that nature supports our well-being, in tangible ways, like these folks gathering honey in India, and in intangible ways, like the mental health benefits you get from taking a walk outside, which are proven to be greater if you can see nature than if you just see concrete, by the way. So today I want to share with you a few examples of how Earth observations are changing the game for conservation and the community of game changers we're building to tackle these challenges together. Specifically, I'll share how we're using Earth observations to monitor biodiversity, to anticipate threats by forecasting them, to prioritize the areas we work so we can save the natural assets that benefit us all the most. And I'll talk about a new effort that we're just launching now to value this information and hopefully make it more valuable. So first, let's talk about how Earth observations can make biodiversity more visible. This is a mangrove forest in New Caledonia. Mangroves like this have some of the richest carbon stores on the planet, up to 10 times more carbon per hectare than you find in terrestrial forests. And that's not all they do for us. These massive root systems you see are like natural seawalls, protecting our shorelines from coastal storm damage. And up to 80% of global fish catch is dependent on mangroves, either as nurseries or as habitats. Here's another mangrove. This one's in the Rufiji Delta of Tanzania. And you may notice that this one doesn't look like it's doing so well. It's faced the myriad threats that mangroves are under worldwide: conversion to shrimp farms, agriculture, coastal development, all compounded by climate change and pollution. To protect mangroves, we first need to know where they are, their exact location, extent, and condition. And that seems like it should be an easy thing to do, but it's not. Mangroves are incredibly hard to survey from the ground. You have to deal with dense, flooded vegetation, mud that might swallow you alive, not to mention the crocodiles. So the result is we don't know where a lot of Earth's mangroves are. And it's even harder for us to track how they're doing over time. Are they healthy or declining, and why? Here's the same place, the Rufiji Delta, as seen from space. WWF is now using satellite imagery like this, along with machine learning, to map the extent and health of mangroves over the last 30 years of the satellite record. And we're also using drones to figure out which species are there and what the canopy looks like. And all of that information goes into this data portal that we can use to help manage the mangroves, and that governments can use in their national carbon reporting so that they can start thinking about conserving these mangroves as a strategy for reducing their greenhouse gas emissions. For the Rufiji Delta, this information helped us build understanding about the ecological connectivity between these mangroves and nearby coral reefs. And that understanding informed a management plan for the whole seascape, which has just been declared a UNESCO Man and Biosphere Reserve this past year. So this is a biodiversity hotspot and supports the livelihoods of 100,000 people. And mangroves around the world are similarly important to their local communities as well as the biodiversity and global climate. So with Earth observations, what we did for the Rufiji Delta, we can do for mangroves everywhere. So we're getting better at knowing where biodiversity is, but can Earth observations help us anticipate the emerging threats before they even happen? Well, before we go there, let's back up a little bit. Mangroves aren't the only forests that are essential to our very survival. Forests the world over form a key part of our planetary life support system by regulating the air we breathe, the water we drink, even the weather we experience. And beyond their material values of wood and timber, they are instrumental in supporting our health, security, our cultural traditions, our spiritual values. But despite all that, forests around the world are under pressure increasingly globally. And we know the extent of this problem very well because Earth observations have already supercharged our understanding of where deforestation is happening. Like these Global Forest Watch's deforestation alerts shown here in pink. But these systems, unfortunately, they often don't provide enough warning for us to take action fast enough. Even the daily trend alerts are not quick enough. And so we wind up recording tragedies like this instead of preventing them. Prevention is not a cure. It's not as good as a cure. I mean, it's better than a cure. And so we need to we need to be able to anticipate these threats and learn about how we can get predictive warnings. So that's exactly what we've built now with this new tool called Forest Foresight. Forest Foresight uses, again, satellite imagery with an increasing library of knowledge of how human activities immediately precede deforestation events, so that we can predict where deforestation is most likely to happen in the near future. And this is a forest in Kalimantan where Forest Foresight predicted deforestation was likely to happen, and it's exactly where it actually happened 8 months later. If stakeholders had been equipped with this kind of information, they could have acted more swiftly to prevent or respond to deforestation. And luckily, that is what's starting to happen now, like in Gabon, where park officials were using Forest Foresight, and they were able to stop illegal gold mining activities and prevent the logging of an estimated 30 hectares in Minkebe National Park. So building on successes like these, WWF is now working with local and international partners to expand the use of this information in the areas where we're already working and testing this tool in yellow, and also expanding to new project areas around the world in blue. With these partners, we aim to reduce deforestation by 30% in the most critical and vulnerable places. But Earth observations aren't just for government enforcement. They also provide a vehicle of empowerment for historically marginalized communities. And this, I want to show a quick video, just a brief glimpse of work that WWF is doing with indigenous communities in Brazil to equip them with drones so they can more easily patrol their forests.
E hoje nós veio fazer uma vigilância e nós veio e soltou o drone para subir. Aí acabamos de descobrir que tem a área desmatada do outro lado do rio Jamari aqui, que é uma área desmatada muito grande. E a pastagem desmatada aqui, ó, olha o tamanho dela, ela é muito grande. Não tem fim, não dá para chegar perto. Essa parte aí que a WWF e o drone vai continuar ajudando nós nessa vigilância, não é só na vigilância, também principalmente na queimada, né? essa parceria que eu espero que não acabe por aqui, que continue. Eu quero ver a floresta em pé. Eu quero ver a floresta em pé, isso que é a minha esperança. Todo mundo junto, se unido, vai, né?
Linking this kind of capability with threats predictions like forest foresight would give these communities a whole new agency over their lands. So the threats we can see coming are now the threats we can stop, thanks to Earth observations. But can this information help us see the diverse values for humanity that lie in a forest, or in any ecosystem for that matter? I hope you're starting to think that the answer is yes. Luckily, values for all of these different ways that ecosystems benefit us, we can now model with Earth observations, diverse, different kinds of Earth observations, land use, land cover, climate, soil, topography, infrastructure, population, you name it. We can see these things. We can put them in these models that represent the way that these benefits travel across landscapes and seascapes, and explicitly, treat each one in its own unique way. And putting all of these values together can help us see the places where we can get the best return on investment, not just the places where it's most convenient or expedient to work. And so the blue and green places on this map are the planet's most critical natural assets for everything other than global climate mitigation, which I'll show you in a second. But these are the places that benefit the most people with the highest amount of value across all of those different benefits. And remarkably, we find that 90% of all of those benefits come from just 30% of the local land area and 24% of coastal oceans. If you add in those global climate benefits, it's only 15% more land area. So Earth observations is helping us more tightly focus our conservation so that we can finally really target the areas we need to save our planetary life support system. The current global investments in natural assets like these are around $120 billion a year. And the UN and the World Economic Forum have already said that needs to at least triple by 2030. So doing this is going to require an array of Earth observations to plan our conservation, restoration, and other stewardship activities, monitor its progress, and report on its impact. So we've seen how Earth observations are giving us much better geospatial data about the state of biodiversity and its trends, the threats facing it, and its values to the world. But now I want to tell you about a new effort, because the opportunities to improve decisions with this kind of information are increasing exponentially. But we all know that decisions are based on a whole lot of other things besides information. So how can we get information to matter more so that decision makers make better informed decisions? Well, this is the answer to that question, we hope. This new effort that we're launching, the Collaborative Network for Valuing Earth Information. It's a growing transdisciplinary consortium that will assess how Earth observations benefit society and how to improve them for a range of sectors and contexts like the ones shown in this box. And ultimately, we want to build two things: a new understanding of the role that Earth observations can play in decision-making, both to improve their outcomes, but also to improve the process itself, to make it more transparent and inclusive and just. And a strong and growing community of practice around Earth observations that can expand the capacity to measure their value and improve the value of this information. We want nothing less than to reshape the way we think about science and the production of information. We have 5 years and $8.5 million to build this community together and to do it. And it's a huge task. So if you are a scientist, practitioner, decision maker, or concerned citizen interested in how Earth observations can help make the invisible visible and how we can hopefully find this path to planetary stewardship, we invite you to join us. You can sign up on this link here. I want to leave you with a story that conveys the hope that I feel for this endeavor. This is Santa Cruz Island, one of the Channel Islands, just a little ways up the coast from here. And on my first visit there, it had this gloomy, foggy weather almost the whole time, just like this. And it was so disappointing. And then one glorious morning, the sun came out. So I seized my opportunity to go for a hike up a ridge to get a better view so I could get my first real view of the island. And I could see the fog on the other side of that ridge still lurking there, so thick it looked almost solid. And as the sun was shining behind me, I could see my shadow on the fog. And as the light hit it just right, it made a rainbow. Not like how you see a rainbow in the sky, like an arc, but a perfect circle, making a halo around my shadow. It was unreal. And I've now learned that this phenomenon, though rare, has a name. It's called a Brocken specter. And there are physical explanations for it, but to me, at the moment, it felt magical, a miracle that only I could see, enabled by the very fog that I had thought up until then was ruining my trip. But what really turned that moment from disappointment to epiphany was light. Light is power. Light makes life, and satellites use light to reveal hidden truths about our world. They have the power to turn challenges into revelations, into opportunities for change. What I've shown you today is just the beginning of that transformation. Thank you.